Hello. My name is Oscar. Together with my colleague Conrad, we prepared this presentation for you. Today, with the 1.0 release of AiiDA, two big things are happening. You will be working this week through making your plugin support the new version of AiiDA 1.0. And all of that was covered by my colleague Sebastian in the last presentation. Now, we also brought to AiiDA PythonFuture support, or modern Python support. My objective here with this talk is to have you understand how you can convert your plugins to run in Python 2 and Python 3. And also make ourselves as a team available to you to make this upgrade as painless as possible for you. So let's see a little bit of motivation, but with 1 year of Python 2 support, like less than 1 year of Python 2 support to go, this is not a lot required, but let's see. Python 2 is at the end of its lifetime. By January 1st next year, is not going to be supported anymore. And let's take a look at what does that mean. Your Python 2 is not going away. Probably Python 2 is going to live forever. It's going to be running in computers all around the world forever, pretty much. But no new features are going to be added to Python 2. And if you find an issue that is actually blocking your development, you're on your own, you will need to fix it yourself. The same thing is happening with libraries. Some libraries are started dropping Python 2 support, among others, Pandas, scikit-learn, NumPy, and those are libraries that are vital for our work as scientists. So what that means is that we can still use the old versions of these libraries with Python 2. But if we want the new features, we will need to jump to Python 3. Also, Python 3.7 is the best Python you can have. Get it today. It supports F strings, which is like a really nice way of formatting your strings. They implemented a new matrix multiplication operator. That is already implemented for NumPy array, so you can do matrix multiplication with that @ sign, and that's a language feature. You can also program in different languages other than English. Unicode is fully supported for all the language. We have also unpacking, and unpacking is really handy for some applications, or in any case to make your code look a little better sometimes. You can have all of these nice features and more features to come, along with safer comparisons, way better memory management, especially for dictionaries, better exception handling and better exception support and tracebacks. You can have keyword-only arguments and all that good stuff. Everything new, everything that is coming new to the language is going to be available only on Python 3 from now on. However, Python 3 doesn't run in all the environments your code and your plugins might need to run, especially, let's say, clusters, or probably older versions of Linux wouldn't support Python 3. Mac OS doesn't support Python 3 out of the box right now. So you might want to consider supporting Python 2 and Python 3. Also, AiiDA, so this is like a rough sketch of our plan, or rollout plan. 0.12, the AiiDA version 0.12 is running on Python 2, and it's going to be supported until some time, not before 2020. AiiDA 1, all versions of AiiDA 1 are going to support Python 2 and 3 until We don't know when. And at some point after 2020, we will release a new version of AiiDA, called it AiiDA 2.0 or 2.x. And the difference with AiiDA 1.0 at some point, hopefully, is going to be that it doesn't support Python 2, just Python 3 only. So what we want to encourage you to do with these last few slides is to try your best to support Python 2 and 3 in your plugins. It's going to be a hassle, but it's going to provide the best compatibility with the different environments where AiiDA is running. Okay, so this is our call to action to you. We want you to update your code and target at least Python 3.6 and above. And if you have, and if you're willing, and basically if you want users to be able to use your plugin in any of the environments they are running AiiDA, I will strongly recommend you that you have a code that works with Python 2 and Python 3. And now I will show you some tools to migrate code from Python 2 to Python 3, and also some tools to make your code compatible with both versions of Python. So we'll start with this library, libtothetree, and it's Python's own implementation of a tool that will take your code. Okay, will take your code and you will run just this command, and it will make everything that was compatible only with Python 2 compatible with Python 3. Bear in mind that libtothetree will produce code that is Python 3 compatible only, and is not compatible with Python 2 and 3 simultaneously. There is another tool called 6, and this 6 tool provides you to do some compatibility between Python 2 and 3 by providing you like some constants, so that you can know when you're working in a Python 2 environment or a Python 3 environment, and you can like do different pieces of code according to the version. And also it provides you with some function wrappers that will do the correct thing in both environments, Python 2 and 3. It will be like the best thing they can do. There is other tool called PythonFuture, and this PythonFuture tool will take in your Python 2 code, and it will convert it to some Python 3 compatible code that is also compatible with Python 2 through this built-ins package. For instance, input, it was called raw input in Python 2, and in Python 3 is called just input. And when you import this from built-ins import input, in Python 3 is not going to do anything, and in Python 2 is going to just rename this raw input into input, and it will just work. So this code will be compatible with Python 2 and Python 3, and the way to achieve that compatibility is through this built-ins runtime dependency. It can also do other thing that is nice. Probably you have already updated your code to work with Python 3 only, and PythonFuture allows you to make your Python 3 code compatible with Python 2. So it goes like back in time. So this is called pasteurize the function. It will take this code that is Python 3 compatible only, and it will make it compatible with Python 2 by importing the runtime dependencies for you. This last tool is the one that we use in the AiiDA project, is Python Modernize. And what it does is taking in your Python 2 compatible code and making it Python 3 compatible, but instead of using some like homebrew package, it uses the 6 compatibility layer as a runtime dependency in order to provide Python 2 and Python 3 compatibility. So by the end, you will use, you will have a code that's compatible with Python 2 and Python 3, but it will depend on 6, but it's pretty normal nowadays if you have a code that is compatible with both versions of Python to have 6 as a dependency. Furthermore, we would like to recommend you to automate as much of this work as possible, so you don't have to think about how are we getting Python 2, Python 3 compatibility, but you're focusing on your code only, and let some tool take care of the details of providing Python 2 and Python 3 compatibility. So beyond those tools to provide the compatibility themselves, we are suggesting you to use a code formatter to keep your code tidy without needing to think about it. You could use JAPF, yet another Python formatter. You can use PyLint in order to spot some errors. Let's say you define a variable but you never use it. You may have wanted to use it but just misspelled it. Prospector runs like a deeper analyzer in your Python code and provides you with some feedback. There may be a problem in this or that line. It will do those kinds of checks in a web that is a little bit more profound than PyLint would do. We're also strongly suggesting you to enable pre-commit hooks using this tool called pre-commit. What that will allow you to do is, for instance, run checks every time you commit. Check with PyLint that everything is okay in your code, and don't let you commit if you have like any problems in your code. So pre-commit will take care of that. Another thing that pre-commit could take care of is automatically making your code compatible with Python 2 and Python 3 using any of the tools mentioned before every time you commit. There is another nice tool called Black that is taking over the world of auto-formatting Python code. It doesn't give you, so different from Java, for instance, it won't let you set the line length, preferred quotes, or anything. It will just decide for you, and you will have it just take the opinions of format and styling. And it does a great job of not breaking your code while styling it. Okay, so this is the section that Conrad was supposed to talk about. So I'm sorry, and I apologize to him and to you if I don't make him a good honor. So what we want to see here is the porting workflow that we used on AiiDA to support to bring support to Python 3 or simultaneous support to Python 2 and Python 3. For this, we use Moderniser, but Moderniser has a feature that allows you to run different changes, like one change at a time. Let's say I want to change all the print functions to use the parents. I can enable Modernize to just do that in my whole code base and don't do any other of the conversions. So this will be the workflow. You start, you apply just one fixer, you make a commit for it, try to run the tests, see if something needs to be adjusted manually. Let's say you call print a variable and then it added parents around the variable and it didn't make any sense. So you need to fix some stuff manually, or at least check that the output is correct. Run your unit test if you have them to make sure everything is working the way it should. And if you haven't, you ask yourself, did I apply all fixes? If it's no, you come back, apply the next fixer, and go on and on till you finished. Once you finish that, you can probably enable the Python Modernize every time you commit and not even care about it anymore. This is just for the first time you run like the Modernize tool over all your code base. Okay, so let me show you one of the cases where Python Modernize or one of these automated tools could get one of the fixes wrong. In this case, we took this Python to code, we ran it through Modernize, and we got this Python 2 to Python 3 code. This code in the, I don't know, in your right, should work with Python 2 and Python 3. However, there is a mistake. In Python 2, if I take the integer of total inches, and let's say I have 6 inches, this division will end up in 0, right? Because division in Python 2 is, integer division in Python 2 works like that. However, integer division in Python 3 doesn't work like that. If you have 6 inches here, 6 over 12, it's gonna yield 0.5 in Python 3. So this is the kind of things you need to take care of when you're running these automated modernizing tools. If instead you tell it to use classic division, so you tell the tool, okay, I need this integer division to actually be an integer division here, you will find that now it screws out the float point division that you have on top, above. So this is the kind of thing that you need to be mindful of when you're running these like catch-all modernized tools. And that's why we suggest that you run these fixes one at a time, so that you can like spot check every change and make sure that it was gonna work the way you wanted it. This is another example where the compatibility layer comes into play. In Python 2 we had raw input. In Python 3, Modernize will import input from 6.moves, and that import is not going to do anything in Python 3, but in Python 2 it's going to just rename the function and make it work as well. Okay, so let's take a look at some key differences between Python 2 and Python 3 that you may need to take care of when you're upgrading your plugins. First, dictionaries. Like the functions that you use usually to operate on dictionaries, like keys, to know what are the keys in a given dictionary, or values or items. In Python 2, this used to return lists. So if you call keys in a dictionaries in Python 2, you get a list of all the keys. In Python 3, it will return a view, which is like similar to an iterator. Okay, so that makes it a little different, because you won't be able to do in Python 3 something like dictionary that keys sub 0, because that's not gonna exist. Has key, as in dictionary that has key, and you pass some key that you're looking for. In Python 2 that works. In Python 3 that's not work doesn't work anymore. You should do a key in dictionary. There is some nice feature called there is some nice features around the key ordering of dictionaries. In Python 2, yeah, so it has never been a feature of the language Python to have, like, if you say dictionary sub A equals 1, dictionary sub B equals 2, if you call keys on that dictionary, you are not guaranteed to get A, B in the order that you inserted the items. In Python 3.6, that was like an implementation detail. For some reason, all dictionaries were were ordered according to when you inserted the keys or how you inserted the keys. And Python 3.7 and above, that's actually a language feature that you can rely on. So that's gonna simplify a lot of stuff. So this is some code example for that. So here we have like all Python 2 code, keys, values, items. All these three will be lists. Dictionary that has key A, of course it has it. And if you, okay, missing key. Okay, you could compare keys to a list of you could compare keys to a list of strings or whatever your key is. In Python 3, however, whenever you call these functions, these are views. You can use the in operator in keys, so that's okay. And you need to call sorted on keys in order to make them a list or make them a list, or you could even need to call list on the sorted keys in order to be able to compare them to that list on the right hand side. Okay. Other consideration that we should have here is that the views are dynamic, nor are not they are not something static. So in Python 2, if you called keys equals d.keys, you will get a copy of A and B as a list of the keys of the dictionary. And if you would remove the key C, if you would add the key C to the dictionary, C wouldn't be in keys, because when you created the list, you created a copy of A and B, and it's not affected for what happened. It's not affected by what happens to the dictionary afterwards. In Python 3, conversely, if you create this view, this is going to be a view of the keys in the dictionary that is actually going to be affected by what happens to the dictionary later. If you add C here and then you try to see if C is in the keys, C will actually be in the keys view. Okay, so for iterators, in Python 2, the function item should usually was a list. So if you had some kind of huge dictionary you need to iterate through, you wouldn't create that. You wouldn't want to create that list in memory, and you will call items in order to create one by one the items of the dictionary. And in Python 3, items has that behavior. So if you want it, and if your dictionaries are not too big, this code in the right hand side is compatible with Python 2 and 3, with the only caveat that in Python 2 this is going to consume a lot of memory if your dictionary is big. Other thing you could do is from 6 use the iterators function that will do d.iterators in Python 2 or d.items in Python 3. So that's a nice wrapper there. Exceptions. So now, in the past, whenever you tried an exception, and okay, so the first difference with exceptions is that in Python 2 we had this message attribute in all exceptions, and that will contain the message of everything. In Python 3, you need to call str on the exception, and there is no message attribute. In Python 3, to get the same behavior as raising a bonus exception or like a custom exception from an exception of the system, you could do this. Create your exception and take in the system exception as a parameter, or just raise your own exception with your own string and just lost the traceback of what originally happened. If you're in Python 3, you could raise your custom exception and add the keyword from the system exception, and that will give you the full traceback of like your exception and what happened before. You can use the 6.raise from wrapper and pass in the two exceptions. Here your custom exception, your own, and here the system or what happened, the reason, and it will do the right thing in Python 2 and Python 3. One final and big difference between Python 2 and 3 is Unicode handling. Python 2 by default did a poor job of letting you know when you were working with byte strings or like just like a chain of bytes as opposed to a proper string, let's say a chain of Unicode characters. And you usually didn't need to care about that until you did. And that was like a really poor approach to it. While Python 3 makes you really aware of when you're working with a string, which is like a set of Unicode characters, or as opposed when you're using like a set of bytes, when you are like working with a set of bytes. For this, so the only thing that you need to know is that you need to be conscious about when you're using a byte string and where you're using string. The Unicode string is the string by default, while if you want a set of bytes, you use prepend a b and call it bytes. And these two types don't equate. So I cannot add a byte string to a Unicode string. I need to first convert it to Unicode and be conscious about it. Or I need to convert the Unicode to bytes. In order to achieve that, I have the handy functions encode and decode. If I take a Unicode string and I want to convert it to a set of bytes, I encode it, and I need to provide the encoding I want. Or I can take the opposite, which is like take a byte string and try to convert it to Unicode. And also, I will need to be cognizant of what's encoding and what all the details are. It's important to know that you will get probably an error when you try to equate those. So when you try to add a Unicode string with a byte string in Python 3, is not going to like it, and it will throw an error in your face, and then you will need to deal with it. But as opposed to before, when you will not get an error, but probably like actually make a mistake in your code. In terms of file handling, there is like huge support in Python 3 for reading in Unicode files, and that gives you support for like reading in any kind of language. And if you really want to read bytes instead of reading Unicode characters from a file, you just open it in binary mode or write it in binary mode. Okay, so the goals for you with Unicode is to be cognizant of when you need to work with the strings, which is like pretty much always, and when you need to work with Unicode, and make sure that you're encoding or decoding the strings that you need to be encoding or decoding. And also, you will need a little bit cognizant about like what encodings are you using for doing these operations. Okay, in summary, Python 2 support is ending, and it's ending like next year, early next year. It's gonna come before you know it. We want AiiDA plugins to support both Python 2 and Python 3, and we'll help you through all these details, so that it is like a painless migration for you. Okay, acknowledgements to Tiziano, who we almost stole all these slides from. And if you have any questions, feel free to ask.